Hello, and welcome to another episode of Tech Time with Justin, a short story presented to you by yours truly. Today's tech topic are graphics processing units and graphics cards, in short, GPUs. In my years of growing up, I have always been a huge gamer, and something that has got me so captivated to the games I play are the graphics and imagery produced in these games. Although I do enjoy good mechanics, I have always been keener towards choosing a game with high resolution options as it makes the experience more ecstatic. Starting off with the birthplace of true graphics, we have the IBM monochrome display adapter for their IBM 5151 PC monitors. And although graphics were being produced before this, these graphics had been produced by hardware built into the motherboard. The monochrome display adapter, however, was the first implementation of a separate hardware component called the graphics card. In 1981, this marvel was released to the consumer market and worked with 80 rows and 25 columns of high-resolution characters, creating a resolution of 720 pixels by 350 pixels on the monitor screen. The best thing about this release in technology was the number of features it came with on its release. There was much more room for customization, allowing for this technology to be versatile in its uses in society, whether it be for game application purposes or work application purposes. IBM's intended audience, however, was mostly for business use, and they created this graphics card to allow for a large collection of different characters so that the monitor could be used internationally. Fun fact, that's what the I stands for in IBM. However, these monitors were provided to also consumers interested in using them for personal displays. And with such a large amount of characters provided, which was 256 characters, people were able to play games. One such game called 101 Monochrome Mazes. And in this game, players were able to traverse 101 different mazes, basically opening up the plausibility of gaming to the market. Now, throughout the rest of the 1980s, there was a lot that happened, but to get the gist and the most important key ideas, the graphics card had a slight increase in its resolution and also had the implementation of a set of unique colors, allowing for better visualization essentially. And due to these implementation of colors and better resolution, plenty of different military, tech institutions, and even NASA became interested in this technology to create simulations, causing for an explosion in companies. A specific example is the CT-5 flight simulator created by Evans and Sutherland, who created their first 3D simulation for pilot training. And due to this introduction of color into the market by graphics cards, we saw also a huge advancement in technology around the graphics card, so basically in computers. It wouldn't be until the 1990s that graphics card companies really start to hit the consumer market again, however. Encroaching into the 1990s, this is where graphics card companies began to really improve the quality of graphics cards, as they began to implement 3D accelerators for both games and animations. Note to self, that during the time, there are countless graphics cards which get released, each successor having improved memory space and quality of rendering onto a monitor. However, I want to highlight that the early 1990s was not fun for many companies. Why, you ask? Well, due to the extreme competition, many companies' graphics cards' APIs were not interchangeable between the different operating systems being released at the time, causing for many companies to be forced out of the market or to be merged into other companies which had APIs that were interchangeable to different operating systems. And well, if you're wondering what an API is exactly, it is the programmed code that allows the graphics card to perform the tasks it does. And well, not being compatible with an operating system means bad news, as this is how the consumer interacts with the graphics card, basically. Overall, as time passed in the early 1990s, many gaming companies were pleased with the results of graphics cards being improved, as they would implement each generation of their consoles or machines with a new and improved graphics card to improve consumer use of their product. It isn't until 1995 where 3DFX releases their Voodoo 1 3D accelerator graphics card to the market. So, To highlight the late 90s, the gist of what happened was a competition once again with all the top graphics card companies trying to create better and better 3D renders. However, it is important to note that the release of the 3D graphics card rendered the old 2D scene obsolete, as this technology became revolutionary as games could as a result be far more in depth with their mechanics. What's most important to talk about, though, during this time, however, was the introduction of the GPU to the market in 1999. Thanks to NVIDIA, they released the first ever chip on the graphics card, which could be considered an actual GPU. Unlike previous graphics cards, which used the CPU or central processing unit to render the 3D imagery, the GeForce 256 allowed for extreme rendering capabilities due to the fact that there was a dedicated processor focused on processing imagery. Now, to wrap up the history of the GPU, once NVIDIA introduces this marvel to the market, it basically becomes the go-to for all graphics rendering systems for computer graphics. However, we see a change in 2007 where NVIDIA releases CUDA, a programming platform which allows for the GPU to be general purpose rather than being specific to only rendering graphics. This begins the era of GPGPUs, also known as general purpose GPUs. This era of general purpose GPUs brought light to highly intensive computer science, as GPUs are able to pump out far more calculations per second than a standard CPU, due to the differences in architecture. You would need a supercomputer to compete with the abilities of a GPGPU. So, as a result of the GPU's abilities and the new accessibility to computer science professionals with the introduction of CUDA, there have been an abundance of different scientific applications released to society, which I'm going to talk about next. So, the application we have here is a CPU-GPU heterogeneous computer system designed to make high-precision calculations to determine what vegetation is a papaya tree. Using images taken by a UAV, the computer is capable of isolating the papaya trees based off of specific conditions, as seen in the image provided about which vegetation is a papaya tree and which vegetation is not a papaya tree. The red dots occur where dead papaya trees or other vegetation occurs, while the yellow dots illustrate where canopies overlap or issues with the actual image caused for misidentification, such as lens blur. Lastly, the green dots, of course, illustrate papaya trees. This was all achievable using a GPU thanks to CUDA, as computer science professionals were able to design this heterogeneous system to have the GPU take on the very intensive calculations, while the CPU does all the managing of the data. This system is very similar to modern personal computers, as the GPU takes on the intense calculations to create graphics while the CPU organizes all the data. Fun fact, this computer uses a NVIDIA 1080 GTX GPU to produce its results, which originally was intended for the gaming market. However, there are several more applications I would love to talk about, such as the use of GPUs in modern AI and using GPUs to graph Earth's atmospheric conditions. However, it is important that we talk about the architecture of the GPU so that you can better understand why this is also achievable. Unlike its counterpart, the CPU, which consists of multiple cores, a GPU is consisted of hundreds of cores. Now, what does this mean? Well, CPU cores are aligned in series with many transistors in each one, which interact with data accordingly. However, GPUs use a form of parallelism, allowing heavy data loads to be split among several different cores, ultimately increasing the number of transistors working on an extreme amount of calculations. The reason a GPU was designed this way was to augment 3D visuals similar to that of a human eye. The GPU takes the perspective camera first, and then begins to calculate for all the floating point numbers in the 3D space to form the objects, then applying textures to these objects, and then shortly after the lighting effects towards these objects from the person's perspective. Overall, the gist of this technology's applications and impact on society was the use of its three-dimensional matrix arithmetics to help solve real-world math and produce outstanding visuals. Wrapping things up, I would like to conclude today's tech topic on highlighting the parallelism of GPUs and the digital world. Thanks to these beautiful small machines, the digital world has become more accessible to people's interaction with astounding graphics, allowing for this market to keep growing and ever more influence our everyday. Thanks for listening, and I hope to see you in the next tech topic.